Have you ever looked up at the night sky and wondered, how did we get here? Not just us, but our entire world? How was our beautiful blue planet, Earth, born? It's a story of cosmic violence, incredible luck, and a very, very long time. Let's travel back 4.6 billion years to find out. Imagine a vast, dark, and cold cloud of gas and dust just floating in space. This wasn't just any cloud. It was a giant molecular cloud, a stellar nursery. Something disturbed it, perhaps the shock wave from a nearby exploding star, a supernova. This cosmic nudge was the starting pistol for the race to create our solar system. The disturbance caused the cloud to collapse under its own gravity. As it collapsed, it started to spin, faster and faster, just like a figure skater pulling in their arms. Most of the material, over 99%, spiraled into the center. The pressure and temperature there became so intense that nuclear fusion ignited. Boom! Our sun was born, a brand new star, bathing the swirling disk of leftover material in light and heat. This surrounding disk of gas and dust is called the protoplanetary disk. It was a chaotic, messy place. Think of it as a cosmic construction site. Tiny particles of dust, no bigger than smoke, started sticking together. It's a process called accretion. First, static electricity pulled tiny grains together, forming little clumps. As these clumps grew bigger, their own gravity started to take over, pulling in more and more material. They grew from pebbles to rocks, from rocks to boulders, and from boulders to massive bodies hundreds of kilometers wide called planetesimals. It was a cosmic demolition derby. These planetesimals were constantly crashing into each other. Some collisions shattered them, while others caused them to merge and grow even larger. In the inner, hotter part of the disk, where our Earth was forming, only rocky and metallic materials could survive the sun's heat. This is why the inner planets Mercury, Venus, Earth, and Mars are terrestrial or rocky planets. Over tens of millions of years of these violent collisions, one dominant planetesimal in our neighborhood swept up most of the debris, growing into a protoplanet we now call Proto-Earth. But Proto-Earth was a very different world from the one we know today. It was a molten ball of rock, a hellish landscape with a surface temperature hot enough to melt iron. There was no water, no air, and no life. It was constantly bombarded by leftover asteroids and comets, a period known as the Late Heavy Bombardment. Each impact added more material and more heat to our young planet. During this molten phase, something crucial happened: differentiation. The heavier elements, like iron and nickel, sank towards the center of the planet due to gravity. This formed Earth's dense metallic core. The lighter materials, the molten rock or magma, rose to the surface, eventually cooling to form the mantle and the crust. This very process gave us our planet's layered structure and, importantly, its magnetic field, which is generated by the molten outer core. This magnetic field would later be essential for protecting life from harmful solar radiation. But our planet's story has a dramatic twist. It wasn't alone. Another protoplanet about the size of Mars, which scientists have nicknamed Theia, was on a collision course with Earth. About 4.5 billion years ago, Theia slammed into our young planet in a cataclysmic glancing blow. The impact was unimaginable. It was so powerful that it vaporized Theia and a huge chunk of Earth's crust and mantle, flinging a massive cloud of molten rock and debris into orbit around our planet. For a while, Earth may have had a ring just like Saturn. Over time, gravity pulled this ring of debris together. It coalesced, cooled, and formed a new, smaller sphere. We call it the Moon. This giant impact hypothesis is the leading theory for the Moon's formation, and it explains a lot. It explains why the Moon is made of rock similar to Earth's mantle, why it has such a small iron core, and why the Earth is tilted on its axis, which gives us our seasons. The Moon's gravitational pull also stabilizes Earth's wobble, preventing wild climate swings that would have made it difficult for complex life to evolve. After the Moon-forming impact, Earth was still a molten world. But over hundreds of millions of years, it began to cool down. A solid crust started to form on the surface, like a skin on hot pudding. But it was a fragile crust, constantly being broken and recycled by intense volcanic activity. Volcanoes spewed out gases from the planet's interior: water vapor, carbon dioxide, nitrogen, and more. This process, called outgassing, created Earth's first atmosphere. It wasn't an atmosphere you could breathe. It was thick, toxic, and had almost no oxygen. But it contained a key ingredient: water vapor. As the planet continued to cool, this water vapor in the atmosphere condensed and fell as rain. And it rained and rained and rained for millions of years. This perpetual downpour filled the basins and craters, forming the first oceans. And it was in these ancient oceans, perhaps near hydrothermal vents on the seafloor, that the next incredible chapter of Earth's story began: the origin of life. But that's a story for another time. So, from a collapsing cloud of gas and dust, through a violent youth of fire and collisions, to the formation of our moon and the arrival of water, our planet was sculpted. It is a story written in the rocks beneath our feet and in the light of distant stars. It took billions of years of cosmic chance and physical processes to create this perfect home for us. It really makes you appreciate just how special this little blue dot is, doesn't it? Thank you so much for joining me on this incredible journey back in time. If you enjoyed this and want to explore more cosmic stories, don't forget to hit that like button and subscribe to the channel. Let me know in the comments what other cosmic mysteries you'd like to unravel. Until next time, keep looking up.